In this video, we're going to talk a bit about mass balance and charge balance as they relate to polyprotic acids and acid and base systems. If you're at all familiar with polyprotic acids, you'll identify the first three equations on the screen as the stepwise dissociation of a triprotic acid in water, giving you hydronium and the conjugate base with each step. The bottom equation is the self-ionization of water, in which two molecules of water react with one another to give hydronium and hydroxide. If we assume that you have a 0.1 molar solution of the initial acid, the H3PO4, then can you work out the different concentrations of all the species present? Go ahead, pause the video, and try to work this out. I'll wait. Are you stuck? You should end up with 4 equations using the equilibrium constant expressions, but you should have 6 unknown concentrations. These unknowns will be H3PO4, H2PO4 negative, HPO4 2 negative, PO4 3 negative, H3O plus, and OH negative. To solve the problem, we'll need to create 2 other equations. These equations are a little bit tricky, but they work for solving the problem. The first one is referred to as charge balance, and in it we equate the positive and negative charges. We can do this since we neither create or destroy electrons during the dissociation of our acid. In this case, the only positive species present in solution is hydronium, and the concentration of it is equal to the sum of the concentration of all of the negative species. Note that there are coefficients listed in this expression for 2 of our compounds. That's because these 2 compounds have a -2 and -3 charge. Anything that only has a single charge has a coefficient of 1, which we do not need to write. The second equation that we need to invent is called the mass balance. Since we neither add or remove phosphate ions in our reaction, then all of the phosphate at equilibrium is equal to the initial phosphoric acid concentration. We can express this mathematically in the following equation. In it, we state that the initial concentration of phosphoric acid, H3PO4, denoted with an I, is equal to the equilibrium concentration of all species containing a phosphate ion. Note that there are no coefficients written in this expression. That is because only one phosphate ion is present in each of these different compounds. If there were more than one phosphate ion in each of these compounds, we would need to include a coefficient. Check your knowledge on mass balance and charge balance with the following problem. Can you get the correct answer? If you had problems with this question, or want more worked examples, please continue on to the next video. If you could successfully complete this question and are confident in your skills, you can continue on and work on your Mabel TA questions. Good luck!